As far as firewalls go, you can look through this slide. You can see there were different firewall types, different generations, generation 1 through generation 5. And it's just kind of the evolution of firewalls. And it doesn't mean that we've stopped using, we'll say, like generation 3 firewalls. We still have, or generation 1, we still see that a great deal, even proxy. It's just different capabilities. And the idea of a firewall is to basically stop traffic from going through that meets a certain condition, for example, or allowing it if it meets a certain condition. The packet filtering is the simplest and least expensive. You could think of a simple Cisco router, one of the simpler ones that are set with access control list. You can create rules within that spell out what can come through and what cannot come through based on simple things like IP addresses and port numbers. It's effective, but not completely everything you need. We hear people talk about proxies or proxy firewalls. And with this, traffic must go through that proxy system. On the proxy firewall's IP address is exposed to the outside of the network. So when you look at the proxy, that's what they see. It's kind of like protecting what's inside of it and what's inside your network, because the proxy server is the only thing that the IP address that is actually seen on the outside. We would normally have some sort of network address translation where we're converting the public IPs to private IPs. It is like a little middleman, it's true. Various types of the proxy firewalls. A lot of times you don't hear the word firewall put with it, but it is kind of associated to be like a firewall. You could have ones that are more circuit level based. We're also looking at SOCs characteristics here. So good for outbound internet access. Application layer proxies, that's the one I think most people identify with, really, not the first two. And with this application layer, you can imagine probably the real popular one is web surfing. So maybe it's being used for HTTP, going out to the internet. So they say one proxy per protocol is required. So super common, and obviously it covers more than just internet surfing that you might be using a proxy for. Stateful, a lot of times I've in the past have called this the best of the best, but it's not the absolute best, but it's a really good one. Many firewalls that want to step above, they don't really want to do proxy services, they don't really want to do stateless or packet filtering ones which we've discussed. It's the same thing. They want to use ones that are a little smarter. They're called stateful firewalls. And it's able to make decisions on more than just the IP address and the protocols or port numbers that you're running. It also is able to do historical comparisons with what packets have been sent beforehand and the condition and the content of the packets. And it basically puts together a table. They call it a state table. And it just has far more intelligence, and it's more likely to pick up any sort of something that looks like more like something a hacker might do, something that doesn't look quite right. So these firewalls are far more intelligent. Dynamic packet filtering, it's like they put some of them together, a combination of application proxies and stateful inspection firewalls. So it's able to be reactive to pre-designed changes in situations. It is considered fourth generation. So if you could imagine putting together some of the nice features of the application proxy servers like HTTP offers, plus the ability to build a state table with, with the stateful inspection, you end up with a far more robust firewall. Kernel proxy characteristics are classified as a 5th generation firewall type. This is built more into the software itself, runs in the kernel protected ring of a computer system. It's integrated with the operating system. Firewall placement, it can be in a variety of places. Firewalls are not just on the outside. It's not like a hard shell with a soft chewy center. Punch through the firewall and you're in. You don't want it to be that. You want to have the firewalls in many different places. So you put it anywhere you think you might need to do some filtering, because maybe there's something trusted and something untrusted. Of course, it's like a demilitarized zone, DMZ, and you can see multiple firewalls in those. You can decide where you want the firewalls to be, but there should be, you know, several firewalls. Showing off some placement, just kind of looking through these slides. You can see they're calling this a screened host. And effectively, you can see in the picture the internet. And it kind of goes through most likely a router, and then you have a firewall, and then you have your systems. So you think of it as a screened device, filter and firewall, followed by, you know, kind of getting into the system and trying to protect the PCs. Those look like servers on the inside. So screening device, filtering router, screened host, firewall. So they're both screening. I guess that's the point here. You're having a good bit of layering. Your router can actually act as sort of a firewall. It does have that capability. When you hear people say multi or dual homed, we have more than two. We have two or more interfaces. And essentially, if you did that to a PC, you would have two network cards in there, for example, if you wanted it to act as a firewall. And a lot of times we call that, we call it dual homed, and just lets you know it's acting as a firewall. In our picture, we can see that that firewall has multiple connections. I mean, you can look at this picture here, and you can see there's obviously an interface going to DMZ1, there's an interface going to DMZ2, it's got a connection going to the right and a connection going to the left. So it's definitely multi-homed. Those are all network interfaces, and of course, it would be, you go through some sort of filtering to decide whether it gets passed through. Screen subnet. Buffer zones created by implementing two routers or two firewalls. You could just like basically create a DMZ, demilitarized zone. You can see the firewalls sandwiching in the DMZ area. So that's a really nice way to go. Wireless. Looking at wireless, we have peer-to-peer and ad hoc. This is not quite as common. Usually you're using something called infrastructure, which uses an access point. But with this peer-to-peer and ad hoc, effectively, I mean, you can relate to the pictures there and say, oh, that makes sense. But essentially, you don't really have the central point. You don't have the central management interface. You could set up a computer and say, I'm going to be the Moonbase wireless network. We just made that up, Moonbase wireless network. And any of you that want to connect to me, I'm called Moonbase. So we could use that to try to transmit between a handheld device. Maybe it's an iPad and your PC. And you could, you know, basically create wireless between you, especially if you're nowhere where there's really like a router. There's no D-Link or Netgear router to be a traditional ad hoc network. I said that wrong, infrastructure network. So you've got an ad hoc, and if you have a router, or have a router like a Netgear, Linksys, whatever brand you choose, that suddenly makes you infrastructure mode. Okay, with infrastructure mode, you have a central point of configuration, just like if you're in your home environment. If you went to purchase a Netgear router, brought it home, and went in there and configured the encryption that you wish to have, hopefully WPA2 would be the very best. And then you set it up, all your devices would have to be configured with those same security settings, and that would be infrastructure. When you purchase these routers, based on the date line that you've bought these, most likely, there were different standards. Now, I don't find that the 802.11 standard, 11A rather, was really that popular. It was pretty nifty though. It had a great deal of speed at the time, 54 megabits per second. It used the 5 gigahertz frequency. That was pretty nifty. But I think in the States, I find that most people started out on B that have been doing wireless for a while. You can think of B as being kind of in the beginning. And unfortunately, it only went 11 megabits per second, but it was a 2.4 gigahertz, which is really popular for the frequency. Then we went up to the 802.11g. And with this, we stayed in the 2.4 gigahertz, but we jumped up in speed to 54. So that was really great. These days, I think most people probably have G or N. Now, they really give in a lot of talk on that last one, but you can look in this chart and kind of get a little bit of a history. Not every letter you see here, as far as the protocol column, is truly represented in reality. I think you'll find historically most people you'll talk to, they may have used B, then they would have perhaps gone to G, and then to N. And you would not have seen necessarily any of the others. But you can see, historically what was out there. And I guess the main specs that would probably be interesting would be the data megabits and the frequency. Now the 5 gigahertz frequency does not have the distance the 2.4 gigahertz frequency has. The N standard, so nowadays we have the N standard, and with that it can do both frequencies, 2.4 and 5 gigahertz. So that's pretty nifty. Here's 802.11n continued. Multiple input, multiple output. Uses multiple antennas to increase throughput and or reduce bit error rates. It is split into 3 categories here. And as far as capabilities, I mean, we really like it because it does have a better coverage area, better speeds, actually. Let me go back to that slide and just check. Let's see, speed 248 megabits. I've seen some sources even say 600, although I think that's probably a little more realistic, the 248. But some books will tell you 600 megabits per second. Sometimes you'll pick up a router and you look at the box and it has the specifications on it. It will actually even say 600. So it's kind of it varies on the speed there. And with this MIMO capability, it's even going to improve some of your other clients if you happen to have some older standards in the house, likely G. Database basics. With databases, when you think of what is a database, it's a collection of information or data that's stored in a computer system, and it's organized with words like files, records, and fields. Fields is a bit of an older term I don't hear as much, but I'm used to saying it because I've been around with databases for a while. Now, database management systems, these are the collection of the programs that let you enter and organize and select data in the database. And there's different types of databases: relational, network, flat, hierarchical. And it's just how it actually organizes the information. Now, relational databases are super popular. Just giving you a little history here. Brands that are products you could recognize, probably Oracle, Microsoft's SQL Server. Those are probably the really big ones, and some others are listed there too. Microsoft Access, that's another one you might know. When you look at database, kind of like database terms, a really popular one is tables. It's a collection of data or data structure linked through relations. Tables are constructed of rows and columns. It kind of reminds me of a spreadsheet, sort of, because you have columns and rows, and when you look at a table, it looks like that. A record set is a requested data, a subset of the entire row. You may have attributes. That term is used quite often. It could be a data type. It could be a currency, the date, characters. I mean, what type of data do we have here? That would help with the attributes. Domain, a set of allowable values. Then an attribute can take. Again, it could be, if I'm currency, maybe I only allow certain character sets, such as $signs. So databases are all around us. It's important to know some of the terminology. With databases, they do have a process called data normalization. And the idea of this is to eliminate any sort of duplicate or redundant data, or repeating groups or attributes, anything that's basically redundant. Trying to make your database not so repetitive, make sure it's efficient. With databases, you'll hear people talk about a language called structured query language, and it does not belong just to Microsoft. What the structured query language does is it lets you control the data from the command line, for example. Some popular ones might be, Microsoft's SQL, or you hear people use, Microsoft SQL uses Transact SQL. Oracle has its own as well. You'll hear commands like update, delete, insert, and so on, drop tables. It depends on which vendor you're using, what words you use. It's a language of its own, but very important. And if you're ever going to be a vulnerability assessor or a penetration tester, the more you understand of databases, the better you would be. and understanding the language with the structured query language. An overview of database servers. We know we have the database management system, and externally we have web browsers, or there may be some sort of piece of software that's called a front end. It's what the users would use to interact with your database, the database front end. We could be looking at views, and that can be programmed to spell out what type of information you wish the customer to see. We could have tables, and the tables can make up the database essentially. You could have multiple tables. Maybe it's a table of your product numbers, and another one is of your customers, and maybe you link all that together. And of course, storage level. In Microsoft, we have NT file system, and you can do security with that. We have access control list, which is kind of a firewall, can be considered a firewall, or in this case, with the ACLs, they're talking more about, it's basically permissions. The NTFS is a Microsoft specific way of doing access control. But then generically, access control lists can be used to dictate permissions, who has what type of permission. So in this very long chapter, we have looked at the CIA triad, the confidentiality, integrity, availability, security definitions, a little bit about TCP/IP basics, malware, viruses, worms, Trojan horse programs, and so on. Network devices and sniffers, a little bit of hubs and switches, wireless standards, BGNA, and database basics.